Welcome to the CompTIA Project Plus Prepcast by baremetalcyber.com. Continuous integration and continuous deployment, often abbreviated as CI and CD, are modern software delivery practices that use automation to improve the speed, reliability, and consistency of code releases. These processes, when paired with beta testing environments and tiered system architectures, allow teams to develop and deploy in controlled, predictable ways. For a project manager, understanding how these elements work together is essential for aligning delivery schedules, reducing risk, and ensuring that deployments meet quality and security requirements. Continuous integration refers to the disciplined approach of regularly merging code changes into a shared repository. Developers commit their updates frequently, sometimes several times per day, and each change triggers an automated build and test sequence. This early and continuous verification process catches defects quickly, reducing the cost and complexity of fixing them. For project managers, CI provides visibility into development progress and stability, enabling proactive intervention if integration issues arise. Continuous deployment builds on continuous integration by automating the release of successfully tested code into designated environments, including staging or production. This removes much of the manual intervention traditionally associated with deployments and shortens the time from feature completion to user availability. For project managers, CD means that release schedules can be more predictable, but it also requires careful governance to ensure that speed does not come at the cost of oversight or quality. The advantages of CI and CD from a project management perspective include faster delivery of enhancements and bug fixes, improved product quality through frequent validation, and increased transparency between development and operations. Automated processes provide a consistent baseline for testing and deployment, which simplifies coordination across teams. This predictability supports better planning for downstream activities, such as user acceptance testing, training, and communications. There are numerous tools that support CI and CD workflows, including Jenkins, GitLab CI, Circle CI, and Azure DevOps. These platforms integrate with version control systems, automated test suites, and artifact repositories to create end-to-end delivery pipelines. Project managers must work closely with DevOps engineers to understand pipeline configurations, release triggers, and monitoring mechanisms so they can effectively schedule deployments and manage dependencies. Automated testing is a core element of CI and CD pipelines, encompassing unit tests that check individual components, integration tests that verify how modules work together, regression tests to ensure new changes do not break existing functionality, and security scans to detect vulnerabilities. These tests run automatically whenever code is committed, producing reports that show pass or fail status. Project managers can use these reports to track progress toward release readiness and to support go/no-go decisions. A beta environment is a dedicated space where near-final code can be tested under conditions that closely simulate production. It provides an opportunity to validate usability, performance, and compatibility before a full rollout. Beta environments can be internal, where testing is done by selected staff, or external, where a limited number of customers provide real-world feedback. For a project manager, beta testing is a safeguard against unforeseen production issues. Effective beta testing strategies involve engaging real users who can assess how well the system meets functional and usability expectations. These programs may target specific demographics or usage patterns to ensure representative coverage. Beta testing is particularly valuable for refining user interfaces, validating workflows, and verifying that integrations behave as intended. Project managers must allocate adequate time in the schedule to conduct beta cycles and process the resulting findings. Feedback from beta testing can come through multiple channels, including surveys, support tickets, usage analytics, and direct interviews. The project manager's responsibility is to organize this input, filter out duplicates, and prioritize issues based on severity and impact. High-priority findings must be addressed before production deployment, while lower-impact suggestions can be considered for future releases. This structured approach to feedback ensures that critical defects are resolved promptly. Tiered architecture, also known as layered architecture, organizes an application into distinct functional layers. Common tiers include the presentation layer, which handles user interfaces, the business logic layer, which processes and enforces rules, and the data layer, which manages information storage and retrieval. Separating these concerns makes systems easier to maintain, scale, and secure. Project managers benefit from tiered architecture because it supports parallel work streams and isolates the impact of changes. Examples of tiered systems include web applications with a dedicated front-end framework, back-end services that process requests, and databases that store information. In enterprise environments, there may also be additional tiers for integration services or API gateways. During testing and deployment, the project manager must coordinate activities across all tiers, ensuring that changes in one layer are compatible with others and that dependencies are managed effectively. Security within tiered environments is achieved by enforcing strict boundaries between layers. This includes implementing firewalls, access controls, and network segmentation so that a compromise in one tier does not grant unrestricted access to others. Segregation of duties ensures that no single individual can alter multiple tiers without oversight. Project managers must verify that these security measures align with organizational standards and are validated as part of deployment readiness activities. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Environment promotion paths in CI and CD define the sequence in which code moves from one environment to the next. Typically, this begins in development, progresses to testing or quality assurance, then to staging, and finally to production. Each promotion step includes its own set of validation procedures, ensuring that defects or misconfigurations are detected before they can impact end users. Project managers must maintain visibility into these promotions, confirming that approvals are secured and that gating criteria are met before any move to a higher environment occurs. Rollback strategies are an essential safeguard in automated deployments. Even with comprehensive testing, issues can arise in production that require reverting to a previous stable version. Rollbacks may involve redeploying a prior build, disabling a feature through a toggle, or restoring a database snapshot. The project manager's role is to ensure that these strategies are clearly documented, tested in advance, and ready to be executed quickly to minimize downtime and disruption. Monitoring and observability practices give teams insight into system performance during and after deployments. This involves collecting logs, tracking metrics, and analyzing traces to detect anomalies, latency, or failures. Tools like Prometheus, Grafana, and the ELK stack can provide dashboards that visualize system health in real time. Project managers can use these monitoring results to verify that deployment objectives have been met and to coordinate immediate responses if critical issues are identified. Deployment frequency and velocity metrics help measure the effectiveness of CI and CD processes. Key performance indicators might include the average time it takes for a change to move from development to production, the number of deployments per period, and the mean time to recovery following an incident. For project managers, tracking these metrics supports process improvement and resource planning, while also providing measurable indicators of delivery performance to stakeholders. Infrastructure as Code, or IAC, is the practice of defining and managing infrastructure configurations through machine-readable scripts. This enables automated provisioning and consistent environment setups. Tools such as Terraform, Ansible, and AWS CloudFormation make it possible to replicate infrastructure reliably across multiple environments. Project managers benefit from IAC by reducing setup errors, accelerating provisioning timelines, and supporting rapid scaling when needed. While CI and CD emphasize automation, they must still align with change control processes, especially for high-risk or compliance-sensitive deployments. This integration might involve embedding approval steps directly into the pipeline or using automated checks to validate that all requirements have been met before a release can proceed. Project managers play a key role in ensuring that these controls are observed without significantly slowing down the release cycle. Collaboration between development, quality assurance, and operations teams is central to CI and CD success. These disciplines must work together to define test coverage, deployment schedules, and monitoring responsibilities. Project managers facilitate this coordination by organizing cross-functional meetings, aligning priorities, and ensuring that all parties have a shared understanding of release goals and timelines. This collaborative approach reduces miscommunication and increases accountability. In agile environments, CI and CD often enable multiple deployments within a sprint, delivering value incrementally to end users. Hybrid models may blend this iterative approach with more traditional milestone-based deliveries. Project managers must adapt CI and CD cadences to fit the agreed-upon delivery model, ensuring that stakeholders are prepared for the pace of change and that adequate testing and training resources are in place. The cost implications of adopting CI and CD include both initial investments in tooling and training and ongoing expenses for cloud services, test environments, and automation infrastructure. Over time, these costs can be offset by gains in productivity, reduced defect rates, and faster time to market. Project managers should work with finance and technical leads to track return on investment by comparing delivery performance before and after implementation. User acceptance testing, or UAT, remains an important checkpoint before production releases, even in fully automated pipelines. UAT environments should replicate production conditions as closely as possible, using realistic data and scenarios. Project managers are responsible for scheduling UAT sessions, collecting feedback, and ensuring that all critical issues are addressed before final deployment. Despite the advantages, CI and CD introduce certain risks, such as the potential for deploying defective code quickly if testing coverage is insufficient. Mitigation techniques include implementing gated pipelines, requiring peer code reviews, and using automated rollback mechanisms. The project manager's responsibility is to ensure that these controls are in place and proportionate to the complexity and criticality of the release. Scaling CI and CD across multiple teams or projects requires standardizing pipelines and best practices. A project management office may develop shared templates, tools, and procedures to promote consistency. Project managers support this scaling effort by encouraging reuse of proven configurations, monitoring adherence to organizational standards, and fostering knowledge sharing across project teams. A comprehensive understanding of CI and CD, along with the strategic use of beta environments and tiered architectures, enables project managers to guide their teams toward faster, more reliable, and more secure software delivery. By managing promotion paths, rollback strategies, monitoring, and collaboration effectively, they can balance the speed of modern deployment practices with the governance and quality controls necessary for long-term project success. Thank you for listening. Please follow baremetalcyber.com on social media and check out our books at cyberauthor.me.